Hi everyone, especially to my grading students. This video is for you. In this video, we will discuss on how to calculate wavelength, frequency, and energy of an electromagnetic waves. So join me now. In our previous lesson, we have discussed that electromagnetic waves can travel through a medium, but unlike mechanical waves, they can also travel in a vacuum or known as the empty space. The different types of electromagnetic waves travel at the same speed, and that is equal to the speed of light. The speed of light has a value of 3 times 10 raised to 8 meters per second or 300 millions meter per second. We also discussed about the different characteristics of an electromagnetic waves, which include the frequency as well as the wavelength. The relationship among the characteristics of electromagnetic waves can be shown by the given equation C is equal to lambda times F, where C represents the wave speed expressed in meters per second, the standard unit for speed meters per second, the lambda for the wavelength in meters, and F frequency in hertz or per second. Please take note that all electromagnetic waves travel at the same speed, which is equal to the speed of light, and as the wavelength of an electromagnetic wave decreases, the frequency increases, or the vice versa. Every type of electromagnetic waves carries a specific amount of energy, the discovery of which was made possible by a scientist named Max Planck. In honor to him, a constant value of 6.63 times 10 raised to negative 34 joules second is introduced. This value is important in the calculations of the energy of the wave. So, we can have this formula E is equal to hf, our second equation, where E represents the energy of an electromagnetic wave. H is the Planck constant, again with a value of 6.63 times 10 raised to negative 34 joules second. Always take note of this constant value because you're going to use this when you compute energy calculations or problems involving energy. Then F represents for the frequency. So E is equal to H times F. Let us combine the two equations to come up with the third one. So first, let us recall that our first equation is C is equal to lambda times F, or wavelength times frequency. Equation 2, we have energy is equal to H times F. H stands for the Planck constant and F for the frequency. So combining these two, we'll have this equation. So how did we come up with this one? So let us go back to the first equation. C is equal to lambda times F, or we can derive that as C over lambda is equal to Because remember that in the computation of wavelength and frequency, you need to know also that you need also the speed of the EM wave. And take note that all electromagnetic waves travel at the same speed. So in other words, it's automatic already that the given speed is equal to 3 times 10 raised to 8 meters per second. So that's the first step. You have to write the given. Then the second step, you have to identify the unknown. So when we say unknown, what is asked in the problem? So in this case, it asks for the wavelength. So under step 2, you have to write the symbol for wavelength, which is lambda equal to question mark. So you have now the given. You are now able to identify the unknown. Then the next step is to write or derive the formula. So generally, we have this formula as C is equal to lambda times F. And what is being asked here is the lambda. So you need to derive this equation to come up with the equation for the lambda. So since C is equal to lambda F, and we need to have the equation for lambda or the wavelength, so let us eliminate F here so that wavelength will remain. So let us eliminate F by dividing both sides of the equation by F itself. So divide by F, F over F will be cancelled. So what is left here is the lambda. Thus, we now have lambda is equal to C over F. This is now our derived formula from this one. So just eliminate the quantity beside it. So since you only need lambda here, you have to eliminate F by dividing both sides of the equation by F. So C over F is equal to lambda. Same goes when you need to derive the equation for F. You have to eliminate the lambda. Okay, so step 4 is to substitute and solve. So this is the last step. So here, so you have now the formula, lambda is equal to C over F. Then after that, substitute the value, 3 times 10 raised to 8 meters per second over 3 times 10 raised to 9 per second. So the numerator will be the value of the speed, 3 times 10 to the 8, while the denominator will be the frequency, 3 times 10 to the 9. If you will see class, the exponent, by the way, because why is this per second? It's because hertz is also the same as per second. So we need to convert hertz into this one so that we can cancel same unit. So 3 times 10, you will see that the exponent here are the exponents for both value are positive, and the denominator is also a positive 9. So if you don't have you can use your scientific calculator, but if you don't have, you can still apply this simple strategy. So since the exponent here is 9, the denominator, you are going to transfer that here. So below 9, you put it after 8, and it's positive, make it minus. So it will become 8 minus 9. If this one is negative, then you can change it to plus. So in this case, this one is positive, so 8 minus 9. So 3 times 10 over 3 times 10, diba, they are just the same. Any number divide by itself, or any factor divide by itself, that is cancelled as 1. So 1 times 10. or what I mean is 3 divided by 3, so we have 1, then copy this 1 times 10. 1 times 10, 8 minus 9, that is negative 1, because negative 9 is higher than 8. So 8 minus 9, that will negative 1. Then copy the unit, cancel the seconds here. This one should be cancelled. Alright, so the remaining unit will be meters for the wavelength. So the answer is 1 times 10 raised to the negative 1 meter, or that is equal to 0.1 meter. This is now the final answer. So I hope you understand the steps on how to solve this problem. It is quite easy, right? Alright, so let's proceed to another problem. Let us deal another problem about wavelength and frequency. So our second problem is, what is the frequency of a radio waves with a wavelength of 20 meters? So again, let's follow the steps. So step 1, write the given. So we have the speed of light, which is constant, 3 times 10 to the 8 meters per second. Then wavelength, and that is equal to lambda is equal to 20 meters, or we can convert this one into scientific notation so that you can compute it easily later. So 20 meters is simply equal to 2 times 10 raised to 1 meter. Why? How to convert this one? Since 20, so you have 1 0, so you have to move the decimal point 1. Okay, so you have 1. So 2 times 10 raised to 1. And stop, you have to move it once only. So make sure that there should be one digit before the decimal point. Or just count the number of 0 like this. So since you have 1 0, then that will be 2 times 10 raised to 1 meter. So wavelength is this value. Next, we have to write the unknown. So what is being asked here is the frequency. So F is equal to question mark. Then write or derive the formula. So again, the main formula is C is equal to lambda F. Then to derive the equation for F, divide both sides by lambda to eliminate the lambda. So eliminate the lambda, you now have C, or F I mean, is equal to C over wavelength, and we are going to use this equation now to solve for the frequency. So take note what is being asked, what is the frequency? So the unknown is the frequency. Then substitute and solve. So write the formula in this way. F is equal to C over lambda. Then substitute. C is equal to 3 times 10 to the 8. Then lambda is equal to 2 times 10 to the first power m, or to the 1. So you can see them here already. Then class, you can, since you're dividing scientific notation, so you can easily divide this even you don't have a scientific calculator. So since you have or you can download scientific calculator, or it's up to you if you will use it or not. But in this one, in this method that I am showing you, you don't need to have a scientific calculator. Okay, so again, let's go back here. So 3 times 10 to the 8 divide 2 times 10 to the 1. So you will see that the exponent here in the denominator is positive 1. So since positive 1, we will transpose it here and change the sign to negative. So the value of the frequency is 1.5 times 10 raised to 7 hertz. As simple as that. At this point, I am going to give you a task since you've done already learning on how to compute frequency and wavelength. So this task is for you to compute now. So you have to write your answer in a bond paper or in a paper. Then you have to follow the steps provided in my discussion. Then once you're done answering the test or this task, you can take a picture of it and upload in Google Classroom. So your first problem is, what is the frequency of a green light with a wavelength of 5 times 10 raised to -5 meters? Alright, so copy the question first, then below the question, you have to write your solution. The second is, what is the wavelength of the microwave that has a frequency of 5 times 10 raised to 8 hertz? Again, what is the wavelength of a microwave that has a frequency of 5 times 10 raised to 8 hertz? Next problem is about energy versus frequency. So our question is, what is the frequency of a photon with an energy of 8.0 times 10 raised to -10 joules? Alright, so still we have to follow the steps, write the given, then you have E is equal to 8 times 10 raised to -10 joule. Remember, that is the value of energy here in our question. So just write the symbol for energy, that is E, and the value. So 8 times 10 raised to -10 joules. Then take note of the constant, the Max Planck constant. So you should remember this always in solving energy. So H is equal to 6.63 times 10 raised to -34 joule second. Take note of this value, then write the unknown. So what is the unknown here? That's the frequency. So the frequency, F is equal to question mark. Then you have to write or derive the formula. So we have here E is equal to HF. So this is for the formula for finding the energy. But since energy is already provided, your task is to compute for F. So you need to derive the formula for F using this one. So to solve for F, you must eliminate this H. To have the formula for F, you need to eliminate this H so that F will remain here. So how to eliminate F? Again, just apply what we have discussed a while ago. To eliminate F, divide both sides by H. I mean, not F, H. To eliminate H, divide both sides by H. So H divided by H, cancelled. So yung maiwan dito yung F only. So E over H. So F now is equal to E over H. So this will be the formula for finding the frequency. Then substitute and solve. So F is equal to E over H. This one we'll just copy. E, just write the value of E, 8 times 10 to the -10 joules, over value of H, 6.63 times 10 raised to -34 joules second. So both have negative exponent, but remember that if the exponent of the denominator is negative, when you transpose it, it will be positive. So, this one, just divide first. 8 divides 6.63. Huwag mo nang i-mind tong sa dulo. Dito ka muna. 8 divides 6.63. You will have 1.21. So, mahaba yan. 1.20666. Just round it off up to 2 decimal places. So, 1.21. Because after 0 is 6. So you have to round it off. So since 6 and 5 and above, so plus 1. So 1.21, not 1.20. 1.21, then copy this one, times 10, then negative 10. Since this one is negative, make it now positive. So negative 10 plus 34. So unlike sign, negative, positive. So you have to copy the sign of the bigger number. So then once you're done, take a picture of it. understand the lessons for this week. So I encourage everyone to answer it by your own. Please avoid the copying the answers of your classmates because it won't help you. Copying or cheating will never help you to succeed. So that's all for today. I hope you have learned from this video, and if you enjoyed or if you learned from this video, kindly subscribe, click the subscribe button so that you will be informed about the new video or educational video that I am going to upload. So that's all. Thank you and enjoy learning. Goodbye.